come and sit down quietly. If you think I didn't mark you here, hit the break. Okay, so we're going to finish up some stuff we didn't do last time. We were talking about properties. Oh, this is still section 1.1. We're going to look at 1.2 and 1.3 today. This properties. Oh, and come on in. I did post, someone asked me to, I posted the assignment a little early. Certainly didn't expect you to do the 1.2 stuff or the new stuff today, but it's on, I guess it's supposed to be Tuesday, and as you should know, I give you an extra week if you need it. So, but I didn't want to panic anybody who was like working through it. Oh, we haven't done that yet. All right. Properties of real numbers, specifically addition. You should know these properties, probably best if you know them by name, but that's not the most important thing. Here's the one that people typically are least clear about. The closure property says x and y are real numbers. Okay, I'm going to do this, for a while I'm going to do this kind of like I'm in a French class. I'm going to translate. And that little e means is a member of, and this funny looking r means for real numbers, the set of real numbers. If they're members of the reals, then x plus y is a real number. That's what closure means. Just means take any two numbers, you get a number. Sounds kind of like meh, but it's an important property. If you think about, this is addition, if you think about division, division is not closed. Why is division not closed? I mean, you take two numbers, you divide them, you always get a number? No, because...
Oh, because of zero?
Because of zero, yeah. Okay. We talked about the associative property. X and y and z are reals. Then x plus y plus z, the parentheses implying the order you do it. X plus y plus z. Doesn't matter what order you add things in. Commutative property, x and y, reals, x plus y equals y plus x. That seems kind of obvious to us. Who here is worked on matrices? Okay, most of you, okay. So matrix multiplication is not commutative. It's associative, but it's not commutative. So, property of the real numbers. I don't know if we do matrices in this class. We might. Identity property. Of 0. That just means that x is a member of the reals. Then x plus 0, of course, is equal to 0 plus x because of commutativity. It's equal The identity is the member of the set that when you apply this operation, doesn't do anything to it. And the inverse property x is a real number. And then I'm going to introduce yet another symbol here. Backwards. And there exists minus x, that's the inverse, such that, this is kind of like French class, you have to learn these different language things. The backwards E means there exists. You could just, if you like, write in your notes, there exists. Such that x plus minus x is the identity. That's the inverse property. This is important because it means if you add something, like we got 7, we start with 7 and we add 5 to it, so we're going to get 12. But there's always a number we can add, -5, which gets us back to 7. Right? That's the inverse property. Okay. You should know these properties. There'll be some little homework. I mean, you should already know most of them, kind of by feel, but here we're being explicit about it. Okay, so we have the same set of properties, or similar ones, for multiplication. And I might abbreviate here. So closure. X and Y are members of reals. X times Y, members of reals. This might be a good moment to just point out that multiplication we indicate in so many different ways here. I have A and B, I can say A times B. Say AB, sometimes they'll say A dot B. It's kind of problematic to use, this multiplication symbol if you've got an X. If you have parenthesis, just assume it's multiplication. Something, just a detail. Okay. Associative property. Property of multiplication. X, Y, and Z, members of reals. X times Y times Z equals X times Y times Z. And commutative property. X and Y numbers. I'm not writing if each time, I'm being lazy and maybe I'm in too much of a hurry, I don't know. XY equals YX. And this is a property that matrices don't have. You can't multiply them, they don't always commute. Okay, what is, I know this is really too simple to be asking, what is the identity for multiplication? No, what is the identity element? The identity element of addition is 0. The identity element of multiplication?
1.
It's 1. So if x is a member of the reals, x times 1 equals 1 times x equals x. may seem kind of obvious, but we use this all the time. I mean, if I write, well, let's say 35 over 15, right? And I want to simplify that, and I want to write it all out. All right, well, that's 5 times 7. That's 5 times 3. That's 5 over 5 times 7 over 3. Is 1 times 7 over 3, which is just 7 over 3. But I don't write all this out. I'm just going to go like that. Right? Because 5 over 5 is 1. 1 times anything is itself. I mean, I'm just saying, we use this stuff all the time. We don't think of it explicitly. All right. And finally, we have the inverse property, which has a limitation with multiplication. There exists, well, if we have x number of reals, then there exists, I'll just stick it in right here, not equal to 0. Then there exists 1 over x such that x times 1 over x equals 1 over x times x equals 1. So, properties of addition, I read that? I wrote that. Addition, properties of multiplication. There's one more important property that combines the two that we, again, use all the time, but we're gonna be explicit about it. Any guesses? What we call this? Where I'm going? Okay. Distributive property. Says if x and y and z are members of the reals, then x times y plus z is equal to xy plus xz. You can go either way. When you're going this way, we talk about factoring out an x. When we go in this direction, we call about distributing the x. Right? Very important for kind of stuff we do. Now a note, we've been talking about the reals. We had some other subsets the other day. Subsets of the reals, sets had the natural numbers, the rational numbers, the complex numbers. They don't all follow all of these rules, right? Natural numbers, well, oh, I left out something. Left out integers, the z for scaling. Natural numbers, oh, it's not closed. No, it is closed. I'm sorry. Natural numbers are closed. We add two natural numbers, you get one. It's associative, it's commutative. There's no identity and there's no inverse. Right? For addition. And there's no inverse for multiplication either. So, that's, interesting questions you can ask about these. Yeah. All right. Any questions on the properties of numbers? my imagination, or is it really hot in here? I guess it was that trip up the mountain. Now, again, I'm just trying to get a feel here. I don't embarrass anybody, so I'll ask it this way. Is anyone here who this is like, I knew all that before? Anybody? Okay, you, okay. Just, okay, so the next topic kind of fits more in what we were talking about on Tuesday. We were talking about sets. We want to talk about a particular type of set called an interval. Interval is a subset of the real number line. And you've probably done this before. You might want to draw x such that x is greater than or equal to 1, and x is less than or equal to 2. So we draw 1, we draw 2. Now, we do this thing in math all the time. We draw pictures that aren't really, lines don't have mid, points aren't little blobs, but we just draw them this way to represent them. So this is what we call a closed interval. Closed meaning the endpoints are included. We could write it this way. Another way we will commonly write it is this. And we will use square brackets to mean that the endpoints are included. And again, we call that a closed interval. If I were to kind of draw the same picture, but with kind of an empty circle here, this meaning x such that x is greater than 1. I'm going to use an at sign for and. X is less than, greater than 1, less than 2. This is what we call an open interval. Open meaning the endpoints 1 and 2 are not included. And here things can really get confusing. The other way we write this is like this. Parenthesis, not angle, square brackets. What's really confusing is this is, yes?
Is that an and or is that an a?
That's supposed to be an and. Do we have any computer science? Yeah, we have a lot of computer science, yeah. See, I'm a kind of a computer science guy in my other life, so I can't help but do this. Because then C language, C++, you name it, JavaScript, Python, and, not bitwise and, but logical and, you would put 2 ampersands. Anyway. Okay, what's confusing about this is this looks like the same notation as we use for a point, an XY point. So you have to figure it out from the context, right? Yes?
On the actual interval line, instead of circles, I always thought in high school we used brackets and parentheses. Is that still on?
Okay. There's nothing absolute about this. Some places kind of like that.
Yeah.
Yeah, that's perfectly good notation too. Open interval, you kind of draw like that. That's fine. You could have x such that one endpoint, but not the other. And that's called a half open interval, half open, half closed. Again, you might draw it like this. And of course, you might have an interval, this, that would be x greater than or equal to 1. In geometry, we call that array. It's an infinite interval, goes on forever. So how would we write that? Well, okay, it's 1. And what's out here? Well, this is not a number. This just tells you it's just going to keep going. And for obscure reasons that we will not have to learn in this class, whenever you go to infinity, we always use open. I see a head shaking. Someone's seen it before. Courage. All right, that's intervals. This will come up, we'll looking at sets, and subsets, things. You could have, I think you could have an interval like this, 1 to 2, union 4 to 5, and that would just be 2 intervals. We also look at intersections, so intersection of 1, 5, and let's make it at least a little tricky. And 2, 7. So what's the union of 1, 5, 2, 7? Well, there's some overlap here, but this just includes everything. And if I figure it out, 1 to 5, and 2 to 7. Well, did I do that wrong? Intersection. Intersection. No. That's not right. That just goes from 2 to 5. Okay. That'll teach me to try and do stuff on the fly. All right. One more kind of disconnected. Any questions so far? I know this is coming fast because hopefully you know most of this. If not, you can stop me, slow me down. Was there a question? No. All right. Last kind of related but a little disconnected topic. Is absolute value. So we write absolute value using the vertical brackets. We want to find the absolute value of what's between them. And definition is absolute value of x. We use this large curly brace to, sometimes we use it to describe a piecewise function, but here we're just using it as 2 parts of a definition. X, if x is greater than or equal to 0, and it's minus x, x is less than 0. straightforward. Absolute value of 5 is 5. Absolute value of negative 3 is 3. Absolute value of 0 is
0.
0. Now, where this gets tricky is if you see this. What's that? Well, go to the definition. X plus 1 equals x plus 1 if x plus 1 is greater than or equal to 0. Well, we know how to handle this. We subtract 1. X is greater than or equal to minus 1. So if x is greater than or equal to minus 1, absolute value is x plus 1. If x plus 1 equals minus x plus 1, if x is less than 0, well, again, how do we know if x plus 1 is less than 0? Well, x plus x less than minus 1. So if x is less than minus 1, then this is minus x minus 1. This comes up, sometimes you're trying to solve an inequality. Like you might have an inequality like deal with that. Well, we're gonna learn how to deal with that, so I won't deal with that. But clearly, excuse me. This is less than 0, and you have to take the negative of it. All right, so there's some basic properties of the absolute value, which should be obvious. Think these through. If they're not obvious, raise your hands. Absolute value of x is always greater than or equal to 0. Obvious. You can't have a negative. Absolute value of x is equal to absolute value of minus x. Now, I'm sure this is like, I used to have this. I cured myself of it. There's a knee-jerk reaction to look at this and think, well, x is positive, so that's why this is positive, and minus x is negative. But x might be negative, right? This is still true, because the negative of my negative number is positive. Similarly, x minus y, absolute value is equal to absolute value of y minus x. Well, that's nice because if something's inside the absolute value brackets and it's convenient to turn it around, you can do that. Why might you want to do that? Well, here's just a simple example. Oh, what's that? Well, I can switch this around just by erasing chalk, and that's clearly 1. Absolute value of x times y is absolute value of x, and absolute value of y. It doesn't matter whether x or y are positive or negative. We end up with something positive over here, something positive over here, and they're both the product of the positive version of x and y. And this is actually pretty much the same thing, except we're using inverses. So these are the properties of absolute value that we're gonna use. There's one more property which is not trivial. It's not simple. It's called the triangle inequality. It says that the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. Let's forget about where, what this means. It's something to do with triangles, but if both of these are x and y are positive, then this is going to be equality, right? Take a look at why that is. Well, this is going to be negative 5 inside, so this is going to be 5. It's going to turn into 3, this is going to turn into 2, it's going to be 5. If both x and y are positive, it's really obvious why. So we only get this inequality if one of these is positive and one of them is, I guess I should say, they're both positive, they're both negative, or one of them 0. I guess that's a little obvious. We only get this inequality if one is positive and one is negative. Well, how does that work? One of them is positive and one of them is negative. Well, this is going to be less than this, because here this negative will become positive and this will be greater. So that's the triangle inequality. Yes?
Wait, because we would be solving in the middle, like in between those two things? Like of the absolute value, the negative 3 plus 2?
Oh, yeah, we solved this inside, right? So this is minus 1. Absolute value is 1, but 1 is clearly less than 5. All right. And the last related information here is I have a line. I have 2 points on the line, A and B. And I want to know the distance between them. Call that D of AB. That's going to be equal to the absolute value of A minus B. Or B minus A, right? This is in such isolation here that I want to give you just a little bigger view that you don't need to know right now. We talked about it yesterday. What if we have an axis? We have A and B. We'll call this AX and BY and BX and BY. Those are the coordinates. Does anyone know how to find the distance between A and B?
I think it's y2 minus y1 over x2.
Your brain is remembering things. It's not all coordinated yet. This is the slope. That's the slope of the line. Everybody, we're gonna do that later in class. No, what's the distance? The distance formula.
y2 minus y, under root the whole thing, bracket y2 minus y1 plus x2 minus x1.
apologize, I couldn't quite make out, but you did say x2 plus x1, and I'm thinking we got ax and ay and bx and by. Do you want to write it on the board, or are you too far back there?
No, I'm rethinking it. I'm rethinking it.
All right, well, let's at least, let's break this up. So here we have ax, and here we have bx. So we can find this distance using our distance formula here. It's going to be this distance. X is going to be absolute value of ax minus bx. This distance, that's going to be ay minus by. Distance y. So I got this distance and this distance. Calling this dy, this is dx. So, yes.
You're going to be looking at Pythagorean theorem,
The-
like dx squared plus dy squared.
Absolutely. The Pythagorean theorem. It tells me that it's going to be the square root of dx squared plus y squared, which, since I'm squaring, I don't have to worry about absolute value, do I? So when you square something, whether it's positive or negative, it becomes positive. So this becomes ax minus bx squared plus ay minus dy squared. Okay. Distance in 2 dimensions, distance in 1 dimension. And we don't have to go there. You can extend this pretty easily to 3 dimensions or 4 dimensions if you need to. Okay. That's section 1.1. Just cooking along here. Most of this should, if it isn't review, it should feel a little like review. Feel like, oh, I'll go look at the homework and I'll look at the book and it'll all come back to me. If it doesn't, well, that's a signal from your unconscious that you're going to have to work pretty hard in this class. And I don't mean that as some kind of threat. I'm just trying to. There's a lot going on here. Okay. Take a deep breath. Switch gears. We're going to talk for a few minutes, quite a few minutes, about exponents. Now, again, this is a topic I hope most of you are familiar with. I'm going to be going pretty fast because of that. Slow me down if there's anything like, wait, I didn't get that. Don't feel embarrassed. Some of you have been away from math for a little while. All right. So, when I write the expression an, and I haven't said this, but usually when I use like n or m, usually I mean an integer, maybe a natural number. Here I'm thinking of a natural number n, and this a can be any real number. What we mean by this is a times a times a times a times a n times, right? So if we have two numbers, a to the n and a to the m, that's going to be a times a times a n times a times a But that's just n times, m times, that's just n plus n. So this is our first, we call them rules of exponents, laws of exponents. Let's start creating a chart up here. Similarly, if I have a to the n and a to the m, and just for the moment, let's assume n is bigger than m. Well, again, I've got a times, or n times. And on the bottom, I've got a m times. Let me draw it this way. You know, a over a is 1. So I can kind of cancel these. And what am I going to be left with? A times n minus n. If n and m just happen to be equal, I'm sorry, question? A and m just happen to be equal, well, they're all going to cross out and we're going to end up with 1, right? But n minus m is 0, so that means that a to the 0 is 1. Usually. Think about that for a second. I'm going to come back to that. We have a to the n over a to the n. Does anyone know where this doesn't work? This isn't going to be right. After a while, when I ask questions like that, some of you will just jump to me. There's got to be a 0 in there, doesn't there? What's 0 to the 0?
1.
Did someone teach you that? Did someone teach you 0 to, now, 5 to the 0 is 1. Negative 1 to the 0 is 1. 0 to the 0. Okay, you want to etch this in undefined. There are people who try and define it as something. It just doesn't work very well. Okay. What happens if n is less than m? Well, so you've got n on top. M on the bottom. You end up removing these all, you're going to get 1 over a to the m minus n. But if you use this formula, that would just be a to the n minus m, which is a negative number, right? That is to say, 5 cubed over 5 to the 6, 5 to the 3, which is just 1 over 5 to 3, which brings us to another important rule, which is 1 over a to the n is a to the minus n. Keep in mind, it doesn't matter if n is positive or negative here, right? It works both ways. So 1 over a to the minus 5 is a to the 5. Usually, like when we're doing homework, usually, and we get an answer like, probably write it like this. I mean, there's nothing wrong with this, it just seems a little awkward. Okay.
I have a question.
Okay, I'm gonna turn around and take your question.
Why is it 3 squared, or like, why is there no negative?
1 over 3 to the minus 2.
Yeah.
Okay, that's this rule here. So minus 2 is n. Minus n is minus minus 2, which is 2. Another way to write this would be 1 over 1/9 equals 9. Okay. Sometimes we need to, we need to do a little mental gymnastics in your head. Flips, right? Flip over. All right. What we want to look at next is a to the n raised to the power of m. Kind of like 3 squared to the 5th. What would that be? Well, what I've got is a times a times a n times the a times a times a n times. I'll repeat this times a times a times a n times. Well, that's just n plus n plus n plus n m times. That's just a to the n times m. Now, we make that part of our list of rules here. This is a really useful rule because if you have a to the n times m, you can break n and m up however you like. If you can factor it into integers, whatever makes doing the calculation easier. As we will see, these don't have to be positive. They don't even have to be integers. They can be fractions, it could be some weird irrational real number. This works. I only showed it, I only kind of gave you a little picture that shows it with natural numbers here. This not being a upper level math analysis course for majors and grad students, we're not going to do that. Okay. Another important rule, if I have products raised to some power, this is AB times AB times AB n times. But the commutative and associative properties let me rewrite this. A times A n times B times B times B So that just becomes a to the n, b to the n. And I'm not gonna, if I merely substitute here for a, 1 over a, which I can do, it's just a number. I'm gonna substitute 1 over b. I get a over b to the n is a to the n, b to the n. And the last rule I want you to look at, which I'm really not going to go into great detail, I think I kind of mentioned this already, is what happens if you get a over b to the minus n. Well, one thing you want to have straight in your head is you have a negative exponent, you change it to a positive, you just find the reciprocal. So this is just b over a to the n. All right. Any questions about these rules for exponents? Everybody's got this, right? Does everybody have a little scrap paper? I want you to try this. Let's try and simplify this as much as you can. We're going to use all these rules here, well, most of them. Take a minute.
Is that a 7 on the bottom? See?
That's a Z. Sorry. Well, that being the case, you work on this, take a break. Take a break and come back. Just take a break and let your fellow students pull the weight. I'm going to take a break. I'll be back. We'll be back in 5. We have some provisional answers here. Anybody? Yes?
I said, if you want me to give up.
No, just the answer. Now, I don't know yet if that's the right answer, but it looks good. You can say, did I want all these to be positive? I don't know. Looks good. You could move this up. That would be okay. If I wanted to get rid of the fraction, you could do that. But yeah, it looks good. So let's go through it real quickly. Anybody else get this? Okay, hey, democracy is not working now. Sorry. But you need to make something right. Okay, so we've got x cubed over y cubed. Okay. Now here, which rule do we have to apply here? A, b to the n is a to the n, b to the n. So the 4 gets applied to the y cubed and to the x. But when I apply it to the y cubed, I have to use this rule, right? Well, So 4 times 3, that's y to the 12th. X to the 4th. We also have my z to the 4th. Okay. So now, okay, we've got y to the 12th over y cubed. Just have to subtract. And my x's, I just have to add 4 and 3. And I've got the same answer. All right. If you didn't get the right answer, you'll have to practice on the homework. This is like a basic skill. Like we'll do stuff in the future where you'll have you'll be learning something else, but you need to know how to do this. Okay. Laws of exponents. Right. Now we get into, I don't know, fun. I think this is fun. What does this mean? You know what it means, good. You don't know what it means, you might think, how can I figure out what that means? Well, you know 5.5 times 5.5, according to our rules, is 5 times a half plus a half is 5 to the 1, which is 5. Let me just call this x here. X times x equals 5. Or x squared equals 5. So what's x? Square root of 5. I could do the same thing, I could say, with 7 to the 1/3.